Hello, good morning. This is Nas from NB Network Lessons. Hope everyone's doing okay. Date today is September 15th, 2024. A lot of requests have come in that I do some Calculus 2 problems. So I've decided to go ahead and start a session on Calculus 2, even though I have done Calculus 1, Calculus 2, Calculus 3, but these are some extra problems which might help you in solving calculus 2 problems and subsequently help you in your test. So having said that, I do have a problem on the board, and I've named it Calculus 2 Lesson 1, and we are basically going to find the volume using integration. So just to recap, derivative is basically finding a slope of a curve, slope of a line, and it's basically rise divided by run. Okay. Whereas in integration, what we do is that we basically divide a curve into small pieces and find the area or the volume. Okay. For example, let's say you have something like this. Right here, you have a curve like this, right? And I want you to find the area between 0 and 5. So the concept of integration is that what you do is that you slice it up into small pieces, slice it up into small pieces, right? Right here. And then you find the area of all these small pieces and then add them together. So that's integration. Okay. So integration is primarily used in finding an area of a surface, area under the curve, or a volume of a surface, and so forth. So I do have a problem on the board, which is basically says that find the volume using integration. You have two functions, y is equal to x cubed, which is the one in black marker right here. Okay, and then we have a function which is y is equal to x, which is basically a straight line. All right, and they want us to find the volume between 0 and 1. Okay, so imagine in your head you have a parabola shaped curve and you have a straight line. Okay, and you're rotating the parabola around this line right here, which is y-x. So you're rotating the parabola around green line. Okay, so they want you to find the volume of just between 0 and 1. So how would you do it? Well, let's go ahead and dive in and take a little bit deeper look at that. So how would you do it? So diameter in this particular case, imagine in your head, you're rotating this parabola around this x, y is equal to x, which is the green line. So then the diameter of the circle would be basically the difference between curves, which is x minus x cubed. Okay, so basically it's the difference between this x and this function x cubed. So that's your diameter right here. If this is the diameter, then what is the radius? Radius would be x minus x cubed over 2. You agree with that? Pretty straightforward, right? Now let me ask you this. What is the area of a circle? Area of a circle is pi r square, right? That's pretty basic. You learned that back in your 8th or ninth grade, right? That's the area of the circle. So now, in this particular case, what we have is a semicircle, right? This is the part they want you to find the volume, right? Not the whole circle, just half the circle. So then you can say AR of semicircle would be half pi r square. No rocket science over here. The full area of circle is pi r square. Half of the circle, you divide it by half. All right. Now what you have to do is you have to basically plug in. So you say AR, you have to plug in the value of R, which we just found right here. This right here. Okay. So that would be equal to half pi into x minus x cube over 2 whole square. All I'm doing right here is plugging in the value of R in here. That's all I'm doing. All right. So when I simplify this, I get, do the algebra and everything. I'm going to skip that step and let you do that. But when you do that, you get pi over 8 times x squared plus x6 raised to the power 6 minus 2x4. Okay. So then what we have to do is we have to basically find the cross functional. What's the cross functional area formula, which is for finding the volume. So then that is going to be V from A to B, A starting point, which in this case is 0, B in this case is 1, A x dx. Okay. Now let's go ahead and plug in. So V is equal to 0 to 1 pi over 8 into x square minus, I'm plugging this in right here, rearranging this and plugging it in right here, 2x4 plus x6 raised to the power 6 dx. Now let's go ahead and integrate that. Okay. Now everybody remembers the formula, how we integrate it, right? So if you have something like that, x raised to the power n time dx, the way you integrate is you say x n plus 1 divided by n plus 1. Just a recap. Okay. So that's exactly what I'm going to do in this case. So then the volume after I integrate is going to be x cube over 3 n plus 1 divided by n plus 1. Sorry, this is 3. Okay. Plus, minus 2x raised to the power 5 over 5 plus x raised to the power 7 divided by 7. Okay. And then what we have right here is we have to find x at 0 and 1. So in other words, what you do is that you plug in value of 1 for x minus, then you plug in value of 0. So once we do that, we get V is equal to pi over 8 into 1 over 3 minus 2 over 5 plus 1 over 7. This is basically, I'm plugging in the value 1 for x right here, minus, let's go ahead and plug in the value 0 now. When you plug in value of 0 for x, this becomes 0. When you plug in value for x over here, this becomes 0. And when you plug in value of 0 over here, this becomes 0. So my friends, when you solve this, your volume is going to be pi over 105 units cube, because volume area is unit square volume is going to be unit cube. So my friends, this was the first Calculus 2 lesson at request of a lot of people saying that they want to, want me to do some lessons on Calculus 2. So this is the first one. Hope you liked it. I did skip some steps, but I want you to go ahead and do that yourself. But basically, I hope you get the idea. I hope you get the concept that what we are doing is that we are using integration to find the volume and using some techniques which we learned in geometry. For example, pi r square is the area of circle. Half pi r square is going to be the area of the semicircle. Okay, and that's what we used in this. So watch this couple of times, maybe more, and I'm sure you'll get a hang of it. Thank you so much for watching. Take care of yourself. Till next time. Bye bye.